Hello everyone. In this video we're going to do a lot of practice problems to help you with the teach me and the homework to draw the Lewis dot structure or the Lewis structure of molecules. Um, and it's a good idea to, there's a blank document, tables that you need to um, print so you can take notes as we go. Okay, the first example is draw the Lewis structure of pH3. So step number one, we're going to find the total valence electrons. And to find the total valence electrons, we're going to look for the columns. Phosphorus is in column 5A. Hydrogen is in the first column, 1A, but we have 3 of them, so we multiply by 3, and we have 8. Second step is to draw the skeletal structure. All that means is put phosphorus in the middle and connect it to 3 hydrogens. So find a way to connect all of them. The next one is electron pairs in bonds. So you're going to subtract how many electrons you used connecting them. So you have 8, and each one of these lines is 2. So 2, 4, 6, so we subtract 6 electrons, we have 2 left. So what we do next is hydrogen is satisfied, it has 2, so we cannot give hydrogen any more than 2, so we put the 2 extra electrons on the central atom. So we'd have connected to 3 and then unpaired electrons, and that would be your Lewis structure. Okay, let's do one more. H2S. The hydrogen is 1, but we have 2 of them, so we multiply by 2. Sulfur is 6A. It's a good idea to have your periodic table. I added the periodic table on top on one of the slides, but I think I added it to the wrong one. So 6 plus 2 is 8. And the skeleton, we just connected 1 sulfur to 2 hydrogens. Now you subtract how many electrons you used in the electron pairs. 2, 4, so we subtract 8 minus 4, or 4 from 8. We have 4 left. So we have hydrogen is satisfied. We cannot add any more to hydrogen, so the two pairs will go around the sulfur. So we have 1, 2, 3, 4, 5, 6, 7, 8. Next one, HCl. H is 1, Cl is 7, so we have 8. 7A and 1A. Draw the structure or the skeletal, we just connect them. And we subtract what we connected with, which is 2, so 8 minus 2 is 6. So all these dots are going to go around chlorine. So 1, 2, 3, 4, 5, 6, 7, 8. So that's the final structure. All right, I think we have one more. Oh, so this one is showing you we have 1, 2, 3, 4, 5, 6, 7, 8. And hydrogen has 2. We cannot give it more than that. So they're sharing electrons. Carbon has 4. Cl is 7. But we have 4 of them, so we multiply by 4. We add them all up. We have 32. Skeletal structure, carbon in the middle connected to 4. So we have 32 minus 1, 2, 3, 4, 5, 6, 7, 8. So 32 minus 8 is 24. Carbon is satisfied because it's 1, 2, 3, 4, 5, 6, 7, 8. So, but chlorine is not. So we add 6 dots to each chlorine, and that's 24. Okay, let's do one more. Si is 4, 4A, and then hydrogen is 1, but there are 4 of them, so we have 8 altogether. We connect them, so we subtract 8. Nothing is left, so that's your final structure. Now, Lewis structure for these. Oh, here it is. I put it on this slide. All right. So NF3. So nitrogen is 5A. Fluorine is 7A, but then we have three of them. So 21 plus 5 is 26. We connect them. So we subtract 6. We have 20 left. We put 6 dots on each fluorine. That gives fluorine 8. But there are 2 left. When we subtract 18, 6 times 3 is 18. We have 2 left, and we put it on the central atom. Oh, here it is. All right. I think this one has double bonds. So carbon is 4. Sulfur is 6. But we have 2 of them. So that's 12 plus 4 is 16. Skeletal, so we just connect them. Carbon with 2 sulfur. And then we subtract how many to connect. So 16 minus 4 is 12. We put 6 on each. That's 12. So we have 8 around sulfur, but only 4 around carbon. That's when we use double bond. So we take 2 from here, 2 from here to make double bonds. So when we make double bonds, each line is 2. So 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 here. And sulfur, we have 1, 2, 3, 4, 5, 6, 7, 8. 8 here. So we satisfied the octet on each element. So we're good. So when you run out of electrons, but around carbon there's now not 8, so that's when you start pulling double bond. BH3. B is in 3A. And hydrogen is 1, but there are 3 of them. We have 6. Connect them. So we subtract 6, because 1, 2, 3, 4, 5, 6. And we have nothing left, and we cannot have double bond with hydrogen. So that's your that's the structure right there. Now this one has charge on it. So the rules are, if it's minus, we add 1. If it's minus 1, we add 1. If it's positive 1, we subtract 1 electron. So let's see. For chlorine, we have 7A. For oxygen, it's 6A, but we have 4 of them. And for the plus charge, we add 1. So it's 32. If you forget about the charge, then you're off a little bit. Now, skeletal, we connect them. We subtract 8 because of what we used. So we have 24 left. Then we put 6 on each to have 8 on the oxygens. This one kind of deformed a little, but that's okay. You know, this is 8 dots, 8 dots, and 8 dots, and 8 dots. Okay, so we have 8 around the central atom. We have 8 around the outer atoms. We did good. Okay, then here's a positive charge. We have NH4 plus. So N is 5A, so that's 5 electrons. Oxygen is 1, but we have 4 of them. And it's a plus, so we subtract 1, we have 8. Skeletal, we just connect them. And then we used up all the 8, and we cannot have double bond with the hydrogen, so we're good. Now I think these are the odd ones, that exception to the rules. So sulfur, SF6. Sulfur is 6A. Fluorine is 7, but we have 6 of them, so we have 48 electrons to distribute. And then we connect them. 1, 2, 3, 4, 5, 6. So we subtract 12 from 48, we have 36. And to satisfy octet, we put 6 electrons on every fluorine. So 1, 2, 3, 4, 5, 6, 7, 8. Now we satisfy 8 around the fluorine, but sulfur, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's okay. We cannot do anything. That's the formula right there. We cannot do anything about it. That's an exception to the rule, so we leave it alone. Okay? Now we have SO, SO3. Sulfur is 6A. Oxygen is also 6A, but we have 3 of them. So 18 plus 6 is 24. Now we connect them. 1, 2, 3, 4, 5, 6. So we subtract 6, and that's 18. We put 6 around each atom. Now this one is, we satisfied the oxygen but not sulfur, so we pull a double bond for one of them. So 1, 2, 3, 4, 5, 6, 7, 8. That's okay. And 8 here, 8 here, and sulfur has 8. Now, when we have one double bond, that double bond is kind of shared between all of them. And one way of showing it is just dots, because when it's rotating in space, you really don't know which one has the double bond. The double bond could be with that one, with this one, or with that one. So it's shared with all of them. SO2. Sulfur is 6, oxygen is 6, but we have 2 of them, so 18. We connect, so we subtract 4, we have 14. 6 and 6, so we have 2 left. But we don't have, we need a double bond. So we pull a double bond, so we have 1, 2, 3, 4, 5, 6, 7, 8. Around the sulfur, we have 1, 2, 3, 4, 5, 6, 7, 8, and this oxygen is 8. Again, it could be, when it's rotating in space, it could be this oxygen or this oxygen. And we call that term resonance, equal sharing of that bond. 3 oxygens, 6A, 3 of them, 18. We connect, so we subtract 4 because we used 4 electrons to connect. We have 14 left. We have 6 here, 6 on this oxygen, so we subtract 12 from 14. We have 2 left. We put it around the central atom. Now 8 is okay on this one, 8 is okay on this oxygen, but the central one is 6, so we pull a double bond, and it could be this one or that one. Resonance. Okay, so this is a formula for ozone. All right, so it's equally shared in space. I think this is the last one. Let's see. NO2 negative. Nitrogen is 5A. Oxygen is 6, but we have 2 of them. And negative charge, we add 1, so that's 18. Then the skeletal, we connect them, and we subtract 4 because each line is 2. We have 14 left. We put 6 on each, that's 12. 2 left, so we put it on the central atom. So to set, this oxygen has 8, this oxygen has 8, but nitrogen has 6, so we pull a double bond. Okay, that's I hope that helps you with the teach me's and your homework. Thank you, everyone. We'll see you next video.